Welcome students to Properties video part 2. So I'm making this in my classroom. It's a little bit different. The sound is probably a little bit different. Hopefully I don't get interrupted too often. If I'm interrupted by the public address system, the PA announcements, then I apologize, but that might come on here and there. I'll try to edit that out the best I can. So Properties part 2. Properties part 1, I have to say, I think we did a good job. It wasn't too painful. You're doing an excellent job in class recognizing our commutative, associative, and identity properties. I added multiplicative property of 0 to the activities in class. So that's another one that we have. And now today we're going to talk about some more algebra properties. And those are the reflexive, symmetric, transitive, and substitution properties. And we're also going to go over the properties of equality. So we say more properties? Yes, awesome, more properties. All right, so let's go ahead and jump right in. The next slide will give you all your definitions. I'll read through them and try to give you enough time to copy them down on that slide. And then we'll work on identifying them and then actually applying them. Here we go, the algebraic properties of equality. We have let A, B, and C be real numbers. So any of these deal with our real number system, which we're also going to work on reviewing in class. So real numbers, remember, include your numbers that are rational or irrational. And under your rational numbers, you have the different subcategories of those as well. And I'm finding that we know those pretty well this year. You guys were prepared really well last year. Whether it was by me or someone else, I have to say, very well prepared. Okay, so I'm actually going to look at the bottom half of this slide first, and we're going to talk about these properties first. The reflexive property says, for any real number A equals A. And what I tend to think about with that is I tend to think about a reflection. So when we think reflexive property, I want you to think reflection. Your reflection looks like you. So A is A. A looks like A, and that's it. Okay, so symmetric property, that's the next one. Symmetric, I want you to think about symmetry. If A equals B, then B equals A. So think about symmetry. In fact, if I was to fold it over, then B would match up with B and A would match up with A. Makes me think of those little butterfly assignments we used to make in kindergarten, where you would put paint on one side and then fold it over and it would make a beautiful butterfly. Okay, so I want you to think symmetry for the symmetric property. The transitive property, this one's a little more involved, so let's look at this carefully. If A equals B and B equals C, then A has to equal C. So the transitive property, I like to think of the transitive property like it's a little train, like it's a little choo-choo train. So let's see if I can draw a little choo-choo train here. Wheels, wheels, wheels. Linked up with another train car. Maybe it has windows on it. All right, so again, I like to think of it as a little train because the three equations are like the three cars on our little train. Okay, transitive property, think train. And there's a little conductor sitting in the train. So it links up together. A is B and B is C, then A must be C. Fourth one, substitution property. The substitution property says exactly what it sounds like. If A and B are equivalent, if they're equal, then one can be substituted in for the other in any equation or expression. So your substitute teacher, think substitution, your substitute teacher is your teacher that takes the place of your regular teachers. Now, I know nobody can take my place, but you know what I mean by substitution property, substitute teacher. Okay, so those are the other algebraic properties of equality that we need to know. We're also going to look at the more utilitarian algebraic properties of equality right up here. Utilitarian because they have a specific purpose in algebra, which is solving equations. So these properties right here, this whole section right here, these are your equation solvers. Okay, and we have, basically, we are just doing the same thing to both sides of an equation. So addition property of equality. If A is equal to B, then we can add C to both sides and it's still equal. Subtraction property of equality. If A is equal to B, then we can subtract C from both sides and it is still equal. Multiplication property. If A equals B, then we can multiply both sides by C and it's still equal. And finally, the division property of equality says we can divide both sides by C and it is still equal. However, C can't be 0. So we'll talk about that in just one second, but I would like you, when you write it down, to dispense with that ridiculous division sign. and maybe make some slanty fractions, or even you could just make them vertical fractions like so. Would probably be nicer. Let me get rid of my scribbly marks there. Okay. So real quick, why exactly is C not allowed to be 0? Well, we're not allowed to divide by 0. Dividing by 0 is not allowed. If we divide by 0 and say, for example, 5 divided by 0, what does that equal? Well, a lot of kids try to tell me it equals 0. Now, the reason that we can't divide by 0 is that that can't be true because you can't go backwards. When you use division, separate example, when we use division, you have to be able to go backwards. 6 divided by 3 is 2, and 2 times 3 is 6. But I can't do that on this one. Because 5 divided by 0, if we try to say that's 0, that would mean 0 times 0 would be 5, and that is just patently false. Not at all true at all. Not at all true at all. So, two et als. But you catch my drift. Okay, so make sure you have those written down in your notes, and yes, the definition is important. I don't want to see just names. You guys know who you are. My folks who are not taking complete notes, please write down the definitions with the names. Okay, pause it if you need more time. Moving on to the next slide. Okay, so as we said, the properties of equality are our equation solvers, and we're going to be looking at one-step equations. Now, an equation is like a balance scale because it shows that two quantities are equal. And so here you have a little scale. Looks like two sailboats and some sort of thing sticking out of it. Anyway, it's a balance scale. Pretend it's a scale. And remember that we're keeping the two sides equal. That means if I add something to one side, I got to add it to the other, or vice versa. If I take something off, I've got to go ahead and do the same thing to the other side. Let's go ahead and look at some equations. And here we are. This is what our properties of equality are for. So here's our first two one-step equations. Now I want you to remember that yes, there are going to be lots of equations you can solve mentally, and that's fine. But you still have to have a method, because there will be equations that involve fractions, decimals, or other kinds of numbers that you don't recognize, and it'll be important that you take the time to actually write out the steps of solving those equations. So let's start with this first one. So we have x minus 2/3 equals 1/3. And remember that we are going to reverse what was done to x, and that's what the property of equality is doing for us. And so what is it that we're going to do to both sides of this equation to isolate that x, to get that x all by itself? I heard someone say it, we're going to add the 2/3. And we're going to add it to both sides. And I do want to see that on your paper for right now. Once we get comfortable with all sorts of equations, I'll be able to be okay with seeing less work, but for now I need to see it so I know you know how to do it. Alright, so I have 1/3 plus 2/3, that would be 3/3, which is the same thing as 1, so x is equal to 1 here. And I can go back and check it, and change my color slightly. 1 minus 2/3, is that 1/3? Why, yes it is. I know I have that right. Excellent, so our addition and subtraction ones are not too difficult today, so moving on to the next one. 9 plus y equals 13. Noticing that I can, if I so choose, switch it around, use my commutative property, make it y plus 9, if that makes me more comfortable. And I know that's stupid easy, so I'll just write it in, minus 9, y equals, yes, that's right, that's 4. Going back, double checking, is 9 plus 4 equal to 13? Why, yes it is, I know I got that right. So, awesome. No problem with our first two one-step equations. Let's go on to ones that we solve with multiplying and dividing. Alrighty, our next two equations. Now, we've stepped our game up a little bit, for example, 2a here. So we're going to jump down and look at b first. And if you haven't read them yet, take a second to look at them. 2.5x equals 1 3/4. 7y equals negative 63. And you might be thinking, Ms. Combs, I think you screwed up here. Because both of these seem to have a coefficient, which means, logically, both of them would be solved using the division property of equality. So the division P for property of E for equality. So you're thinking, well, that's both of them. So didn't you kind of mess up? You were supposed to give us one of each. Well, in reality here, the easier way to do this problem is not going to be this one up here, this one up top, is not going to be the division property of equality. Because we don't really divide by 2.5. We're not using graphing calculators yet. The ease of fraction math with a graphing calculator is pretty fabulous, which I will teach you, but we're not doing that yet. I need you to be able to do this without that graphing calculator. So while we will use that division property of equality for the bottom one, we're actually going to end up using the multiplication property of equality for this one. So the multiplication property of equality. And we're going to be incorporating our inverse property of multiplication too. That was from properties part 1. or you could say multiplicative inverse. Okay, so those are the two properties we're going to be utilizing, messy, on that first problem. So rather than doing this one and then A and then B, let's do B first. Okay, let's do B first. Let me get rid of this so it's out of my way. Okay, so 7y equals negative 63. So I'm going to divide and divide because I see multiplication. I'm using that inverse, backing my way out of what was done to the variable. Divide by 7 and 7, negative 9. Check my math. Yes, indeedio, that's correct. No problem there. We got that right. But with the first one, what I want you to see here is that we want to make our ease of doing the math. We want to find easier ways to do the math, and we want to try to prevent ourselves from doing more work than we have to. And that's why we're going to use our multiplicative inverse and multiplication property of equality on this one. So I got 2.5x, which looks really awkward, doesn't it, with a mixed number coefficient? Very strange. So let's fix that. Let's make it an improper fraction, which means denominator times whole number plus numerator. So 2 times 2 plus 1 is 5 halves x equals, and let's go ahead and let's make this also an improper fraction at the same time. It's going to make the math easier. In fact, improper fractions are preferred in algebra and above. Mixed numbers are kind of passé. We're not going to use them anymore. We really don't need them. It makes better sense to use an improper fraction. But let's go ahead and change this to an improper fraction. Multiply, add, so 4 plus 3, 7, so 7/4. Now to solve this, we're not just going to use that multiplication property. We're going to use that multiplicative inverse property. So we're going to think, what could I multiply 5 halves by that would give me a 1? Because you know our goal here is to get 1x equals, well, something. We don't know what it is yet. So again, multiplication property of equality, what would that something be? That's right, that would be the reciprocal of 5 halves, which is 2/5, which is a convenient multiplication if you look over here on the right, because I can simplify with the 4 and the 2, dividing them both by 2, multiply across the top and across the bottom, and there we go, we have our answer. And we're done with that problem. So we end up with x equals 7/10. I know that some of you are probably uncomfortable with the color change there. I apologize for not switching back. Here, let me fix it for you. So it turns out the app is kind of being a jerk and it won't let me erase it, so I had to draw over it in the other color. So forgive me, my folks who need their symmetry and their colors to match and all that. But anyway, let's double check that, make sure we did that right. So I'm going to go back, excuse me, I'm going to go back to this step before I started solving it, and I'm going to plug in my 7/10 value. And I immediately notice that I can simplify here, dividing by 5, so that's a 1, that's a 2, and we end up with 7/4. 7/4 is indeed 1 3/4. Boom, we got it. No problems. And that's that for this video. I don't think it ended up being too long at all. I'm going to go ahead to the last slide so we can see what I gave you. Yes, that's right. I want you to solve all the equations. So I'm going to have a little throwback to Miss Cervantes. That most of you don't know. What she likes to do at the end of her videos is tell you to get up and dance. So let me find some good music for you to get up and dance. In honor of school, I made a selection. So let me go ahead and play a few, maybe a minute or so of it for you. Here you go. Come on, get up. Get up and dance. I'm sure you're by yourself. It's fine. No one will see you.